Hello, boys and girls. Today we're going to be reading Animals in Flight. This book is by Steve Jenkins and Robin Page. This book is all about wings, and it's about who has wings. So tiny insects, butterflies, birds, and there might even be some dinosaurs. We're going to be thinking about how they go through the sky and how they use their wings. What do their wings do, and how do their wings work? We're going to be trying to answer these questions as we read today, so pay attention closely. We're going to be reading this nonfiction book to learn more about wings. That's the author's purpose. The author's purpose is to give you more information about wings that you might not already know, or it gives you more details that you can add on to what you already do know. So let's get started reading. Animals in Flight. You can see our title page. And here we go. Imagine being able to fly, soaring, swooping, diving, or hovering. So many animals are able to do what we can only dream about. How do they do it? When and why did they take to the air? The author includes more information at the bottom. The barn swallow, a fast and graceful flyer, spends up to 18 hours a day in the air. This is more information about this bird here. So it's almost a caption to go along with the photo. And this is actually an illustration because the author has drawn this. This is not a real barn swallow, but a picture drawn or an illustration. Insects were the first flying animals. The ancient dragonfly lived almost 350 million years ago. Larger than any insect alive today, it had wings measuring 2.5 feet across. So that's pretty tall. It's 2 rulers and 6 more inches. So that's a lot of inches, and that's a pretty big dragonfly. So the author includes this illustration to show you what a dragonfly looks like. And now dragonflies are much smaller. So this is the caption that goes along with the illustration. And here we have a sidebar. The author includes lots of information. We're about to read it. The author says, "How did insects begin to fly? No one knows for sure. Some insects may have had flaps on their bodies that they use to warm themselves in the sun. Or they may have had started their lives in the water and had fins for swimming. When these insects jumped to avoid danger, some were able to glide to safety with the help of these fins or flaps. After 1,000,000 years, most insects had developed real wings and had spread to all parts of the earth. One of these insects, the ancient cockroach, was 1.5 feet long, so it used to be very long. Now cockroaches are much smaller. They're about like this long. Here we go. I see a dinosaur. I wonder what the author is going to be telling us about on this page. Then, about 250 million years ago, small dinosaurs began to fly. The first flying reptiles were small animals that were related to dinosaurs and lived in trees. Eventually, some of them became quite large. The pterodactyl, which lived 175 million years ago, had a 17-foot wingspan. So that is a caption that goes along with our illustration here, showing that dinosaur, the pterodon. And then we also have 2 more illustrations here, and we're going to read the captions that go with them. Archaeopteryx, which lived 150 million years ago, was the first true bird. It had feathered wings and scaly skin like a reptile's. The largest of the flying reptiles was the Quetzalcoatlus. Its wings were 40 feet across. the modern-day bald eagle has a wingspan of about 7 feet. So this is showing you how big, this is a diagram that shows you the Quetzalcoatlus and then the eagle. So the eagle is the black one now, and this one was the old dinosaur. And here we have our other first feathered bird. Flying helps animals escape danger, find and catch food, and move from place to place. Here we have a caption. A robin uses flight to escape danger. It may also fly to catch insects, to reach seeds or fruit that other animals can't get to, or find a safe spot to build a nest for its young. We've read about nests this week. The barn owl's wings are covered with soft feathers that make no sound as they swoop down silently on unsuspecting mouse. So here we have another image, and this is more information in the sidebar. The author tells us about another animal that uses its wings and how it uses its wings, and we learned about the robin and how its wings help it to stay safe, catch food, and move from place to place. So that's important information that the author gives. So here we have some information. Different animals have different kind of wings, but they all work by creating lift. Reptile wings, here's the example of the illustration. Insect wings, bird wings, and bat wings. So reptile, insect, bird, bat. And these 4 types of wings all look different, but they work the same way to help lift the animal into the sky. Here's some more information. Lift is the force that gets an animal up into the air. All wings, animal or man-made, create lift in the same way. The shape of a wing causes the air moving above it to travel faster than the air passing below it. As the air moves faster, its pressure is reduced, and the result is higher air pressure beneath the wing that pushes upward, lifting all the wing and the flyer into the air. All flying animals, past or present, have wings. So all animals that fly have to have wings. Animals use their wings in different ways. Some can hover. Most insects can fly like a hummingbird. When a housefly wants to land on the ceiling, it hovers right side up, lifts its front legs until its feet touch the surface, and then swings its body around so it is upside down. So here we have the example of a fly, an insect that has wings. And here we have a caption to go along with our illustration. This is a hummingbird. You can see the hummingbird is sticking its beak into a flower. The hummingbird is the only bird that can hover or fly in a place. Hummingbirds can also fly up, down, sideways, and backwards. So hummingbirds can fly in certain patterns. And here we have a diagram to show more about the hummingbird. And the author includes a sidebar of information. The hummingbird's wings can act as helicopter blades, pushing the air down or sideways. This is how the hummingbird can fly in any direction. So then there we can see our diagram of how the wings are working for the bird. And here we have our sidebar. Others can dive, soar, or turn in loops in the air. Ducks often travel in a V formation. except for the leader. Each duck is particularly pulled along by the air currents created by the bird it flies behind. It takes more work to fly at the front of the V, so the ducks take turns leading. So here, the author includes information about what it's like to fly in a V-shaped formation. On the next page, we have another illustration, and we have some more information that we're about to read. Soaring birds like the vulture ride updrafts or rising currents of warm air called thermals. These birds may be able to stay aloft for hours without ever flapping their wings, which are large for their bodies. Bats have very flexible wings that allow them to change direction quickly. Most bats feed on flying insects, so they have to be aerobic flyers. They can fly upside down, spin, or turn in loops in the air. So when they turn in loops, they do this for a reason, and that's to help them to catch food. And when they turn in the air or dive or soar, helps them to catch their food or their dinner. And then down here, there's a caption as well. It says, the peregrine falcon, the fastest bird of all, can reach speeds of 175 miles per hour in a dive. That's faster than most cars go. Here we go. The author gives us a diagram with labels and more illustrations and information. So let's go ahead and see what the author is talking about here. Feathers, light and strong, create a large wing surface to push against the air. They also keep the bird warm to conserve energy. So that's label number 1. Hollow bones keep the bird's body light. Strong muscles power the wings. A streamlined body more easily moves through the air. So that's the information here. Some birds are unable to fly because they're too heavy or their wings are too small. These birds are able to get around in other ways. The ostrich, which can weigh as much as 300 pounds, can run as fast as a horse. The penguin is a graceful swimmer and spends most of its time in the water. So these two are birds, and they have feathers, but they don't fly like other birds. Birds use more than just their wings to fly. In fact, their whole bodies are made for flight. So their whole body is made to fly. And that was what we read here. The author was giving us information about how they use their bodies. So again, reviewing that information, they have their feathers to create the flow of the air. They have hollow bones to keep them light. They have strong muscles to keep them in the air and help them move. And they have a streamlined body that helps them move really easily through the air. And that's all ways that a bird uses its bodies to fly. Insects are the most common flyers. It's believed that there are more than 1 million different kinds of flying insects. So here you can see a common insect, which is the bumblebee, and we can learn a lot more information the author gives. The author says in a caption over here, the honeybee, like most insects, has 2 pairs of wings. So it doesn't just have 1 pair, 1 on each side, it has 2 on each side of its body. And when a wasp begins to fly, its wings move down and forward like a bird's to create lift. As the wasp rises them for the next stroke, however, they twist upside down, and this provides them lift on both sides to go up and down. And then here we have more information. When a butterfly is resting, it holds its wings upright and together. When it's ready to take off, it rapidly rapidly pulls its wings down and apart. So rapidly means very quick and fast. This creates suction that pulls the butterfly straight up into the air. And here we have another insect, which is the ladybug. And the ladybug, like all beetles, has a pair of front wings that are hardened into a protective covering. And when the ladybug flies, it swings these hardened wings outward and forward and beats its back wings. And the front wings don't flap, but they provide a lift once the ladybug is flying. So we see lots of illustrations in this text to help us to see what it looks like with these animals with wings. Bats are the only mammals that can fly. And so here we have a bat in caption. It says, the vampire bat feeds at night on the blood of other animals. So that's not about his wings, but that's another fact that the author gives. So an important detail would be that bats are the only mammals that can fly, but this is another detail that the author gives for us to learn more information about the bat. The bat's wings are supported by 4 very long fingers. These flexible fingers and the thin skin stretched over them allow the bat to twist its wings into almost any shape it wants, making it possible for the bat to change direction very quickly and gracefully. So the bat can change directions really quickly. His body is built for flight. Flying squirrels, flying fish, and flying frogs can't really fly. They are gliders. So let's learn more about gliders. Most gliders can travel from 50 to 100 feet in the air. The flying fish holds the animal gliding record, 1/4 of a mile, more than 1,300 feet. Flying squirrels are a glider. Flying lizard is a glider. Flying gecko is a glider. Flying fish and flying snake. So all of these animals here are illustrated and shown because they are gliders, similar to the gliding frog we see here. The flying frog uses its skin stretched between its toes to glide from tree to tree. Like other gliders, it doesn't have wings and is unable to create enough lift to overcome gravity. So it's not a true flyer. So here is our caption that tells us more about our flying frog. So he can't go long distances, but he can glide from lily pad to lily pad, or from place to place to get him to where he needs to be. The largest and smallest flyers. So let's see what the largest and smallest are. So I can see a picture of a bird here, and the author includes a caption, and then there are many animals on this page, so we're going to go through each one. The albatross uses its large wings to soar over the ocean for days at a time. So when they're flying over the ocean, there's nowhere for them to land, so they're flying for a really long time. And that's this guy right here. Okay, so the fairy fly, only 1 1/25 of an inch long, is the smallest and tiniest insect. So they show you this tiny, tiny dot that you can barely see right there in the center. And to show you how really, really tiny he is. So he would be very, very small, barely big enough to see through your finger when you make a hole. The bumblebee bat is the world's tiniest bat. It has a wingspan of 6 inches, and it weighs less than a penny. Here we have the bee hummingbird. It's the smallest bird. Its body is less than 3 inches long, and its wings measure 6 inches long. Here we have The largest flying insect, it's the Queen Alexandra bird wing butterfly. It measures 12.5 inches long from wingtip to wingtip. Here we have the Indian flying fox. With wings, it's 6 feet across. It's the largest bat in the world. And here we have the albatross. It has a wingspan of up to 12 feet, the largest of any bird. So this albatross is the same as here. The author gave us more information in the caption. So now we learned about some large animals. Big and large are synonyms. And we also learned about small or tiny animals. Small and tiny are synonyms. Words that mean the same thing to help us understand something. All right. Fastest, farthest, highest world record flyers. So now we're going to learn about these fast animals that hold the record for fastest, farthest, and highest. This is our horsefly, right here. The horsefly can reach speeds of 30 miles per hour or more, making it the fastest insect. The spotted whooper swan holds the record for the high altitude flying. It's been seen flying 27,000 feet above sea level. Wow, that's high. The fastest bat, the big brown bat, can fly at 40 miles per hour. The Arctic tern flies a round-trip distance of 25,000 miles every year as it migrates from the Arctic to Antarctica and back. So it goes from the north top to the south, and from the south all the way back up to the north. The monarch butterfly migrates from the Great Lakes to Mexico every fall. A distance is over 2,000 miles. So these animals use their wings to travel far distances and to get to different places. So animals use their wings for a purpose. The spine-tailed swift is the fastest bird in level flight. Not in a dive, it can reach speeds of 112 miles per hour for short periods of time. Inspired by animals, humans have dreamed of flying for centuries. An early unsuccessful flying machine, unlike birds, humans are not made for flight. A man of an average weight of 150 pounds would need wings about 140 feet across to fly successfully. Even the strongest man would be unable to flap wings so large. And so this is why people don't fly by themselves, because we would need very, very large wings to be able to get up into the air. The helicopter was built in the 1800s, didn't work, because it's very difficult for a human to generate enough power to lift his body into the air. And so this helicopter here looks a lot different than what we have now as a helicopter. Here we have the first human flights were made using balloons, so hot air balloons. In 1903, the Wright brothers piloted the first working airplane. It traveled just 120 feet in initial flight. A modern passenger jet flies at speeds of more than 500 miles per hour. The fastest plane is the SR-71 Blackbird spy plane. It was built by the United States in 1961 and can fly 3 times the speed of sound over 2,000 miles per hour. That's very, very fast. So all of these things over here are additional information the author is giving us about how humans have tried to fly. Great illustrations. And finally, this is just a glossary of all of the different animals that were found in the book, and the author gives lots of great information about these animals. So I'm just going to hold it up for a second for you to look. So you can see that the author uses bold words to tell you more information about barn swallows. And then you can also find more bold words, just like dragonfly. So you can find more information about different animals that were found in the book that we read about. And this is our ending page. I hope that you enjoyed our book, Animals in Flight, today, and I hope that you learned more information than you already knew about how animals fly, why animals fly, and how animals use their wings to do different things.